Okay, class, welcome to another day of science class. We have our helper today. Let's say hi to James again. All right. Okay, good. So today, class, what we're going to do, we're going to be talking about a new term today in our force and motion unit. And the term that we're going to try to understand today is the word inertia. And inertia is actually Newton's first law of motion. So this is what we're going to do. Before we get to that word, I want you to ask you a question. We have two vehicles here. We have the blue truck and we have the red truck. One is obviously bigger than the other. Which of these trucks do you think would require more force to stop? Which one is going to take more force in order for it to stop? Okay, now let's go over our term here. So the term we're going to be talking about today is called inertia. Inertia is the tendency of an object to continue to move at the same speed and direction as it is currently moving. So it is its tendency, the tendency to do that. So basically an object in motion is going to stay in motion unless acted upon by another object. An object at rest will stay at rest unless acted upon by another object, okay? So inertia is not a force. Now we talked about a force in our last activity. That force is a push or a pull. And you saw how James and I pushed, or I kind of pushed and pulled him, pretending, of course. But anyway, so inertia is the tendency. What is the tendency? The tendency of an object to continue to do whatever it's doing. So if an object is moving, the tendency is for that object to continue to move unless something stops it from moving. Okay, does that make sense? Okay, good. So let's look at our activity today. So what we're going to do today, we're going to have James. Come on over here, James. James is going to be the one doing the assignment. And then, of course, I will be the reader as usual. So the first thing we're going to do, we're going to be using a balance because you can't feel what I feel. So I have a balance here just to help you to believe that the two different marbles I have in my hand have different masses, okay? So I'm going to ask James to first find the mass of our metal marble, and then he's going to find the mass of our white marble. But before we do that, let me read, okay? It says, it takes more force and often more time and distance for a heavier car to stop or swerve to avoid an accident. A heavier car has more inertia than a lighter car. Inertia is the resistance of an object to changing its motion. In other words, inertia describes the tendency of an object to continue moving at the same speed and in the same direction, such as a train traveling in a straight line at 60 miles per hour. Continuing at the same speed may mean a speed of zero meters per second or continuing to not move. The more mass an object has, the more mass that the object has, the more inertia it has. And the greater the force it takes to change its motion. So here you can see, class, that we have these two, you see this, Jimmy? We have these two trucks. The one that has more mass, okay, the more mass an object has, the more inertia it has, and the greater the force it takes to change its motion. Understanding inertia helps us understand and predict what a vehicle will do when forces are applied to remove, applied or removed. Okay, here we go. So the question today is, how does inertia affect how an object moves? So once again, we're going to have James. Ready, James? James is going to find the mass of these things. Now, this right here is a balance, okay? It's not the kind of balance that we will use in my classroom, but this one is just the one that we're going to use today. So, James, I want you to find the mass of our marble. Now, why do I have this cup? Because the marble, you can see, it's going to roll off here, right? So I have a lid to help us. So we're going to put this lid on here, and can you see if the lid's showing any kind of mass there? Is there mass in that lid?
Yes.
Okay, so we are going to re-zero it. So James, can you push the re-zero button, please? Okay, now he will be able to find the mass of our marble. Okay, we are not going to write this down. It's just to help us to see that the metal marble is really more massive. So what's that? What's the mass of that marble? Can you say it, James?
16.6 grams.
Okay, good. So we're going to find the mass. Remember that number, 16.6 grams. Now we're going to find the mass of our white marble. So is that back to zero, James? Okay, good. So let's put this on it now. What's the mass of that?
5 grams.
Okay, 5 grams. So this is not part of our experiment. I just want you to know that this one is really more massive, and I had to prove that to you. Okay, now we're ready for our assignment. Okay, so here's the assignment. So James, you're going to just listen to me, and you're going to go for it. Okay, so set up the circuit track as shown, as I already said it for us. Practice sending the metal marble clockwise, counterclockwise. James, can you do that for us, please? Around the inside of the circle track. So we don't need these anymore. That was just for show and tell. Okay, go ahead, James. Yeah, go ahead. A little faster. Can you go a little faster around? Okay, you see, everybody see that? Can you see that metal bar going across? Okay. Now it says set the opening to A. So we have our data sheet. And here is our data sheet, class. Here's our data sheet we're going to use today in class. And you can see here that we have opening A, opening B, and opening C. Okay? So we are predicting, what is this marble going to do? What is this marble going to do? Okay? So today you are going to look at the two marbles and determine what the tendency of the marble is. So what is the tendency of this marble when it leaves this track? Okay, what path does it take? Okay, so if you look here, we're gonna set it to A now. So James is gonna set it to A. You get on A. Okay, now we're gonna put it this way so that when it does something, now James is gonna put his cone. James, here, James, put the cone where you think the marble is gonna go when it leaves the track. So you're gonna go around that way. Yep. Where is it gonna go? Predict where you think it's gonna go, and put the cone there so it hit it. There you go. Okay, good. So look, class. On your paper, you're gonna make your own prediction. Okay. So if you look here, class, we're gonna use X's for prediction. So on your paper, James, can you do your prediction here? Can you put 3 X's wherever you think it's gonna go? How about I predict? I think it's gonna go this way. Okay, so I'm saying that when he puts this marble counterclockwise, that the marble is going to come out this way. This is my prediction. You're going to have a prediction for each of these spots. Okay, that makes sense, class? Okay, good, James. So James has made his prediction. Go ahead, James. Can you roll it around now? And let's see if he's right, class. Try to go a little faster than marble. Oh, he was close. Now, Jimmy, you get that? Should we go a little bit slower? Let's see if we can go a little bit slower, James, so everybody can get it. Oh, that time he was correct. I think he moved it, though. I saw him move it here, buddy. Okay, good. One more time. Do it again, James. Okay, good. Now, class, we're going to draw the actual path. So let's make the paper look like the opening there. What was the actual path that it took, James? Can you draw that? Now this time, if you look here, the actual path is going to be drawn with a straight arrow. Okay, here we had 3 X's for our prediction. Now the straight arrow. James, how about I just draw it? Do you remember how it went? It went this way. It went, and this is the actual path it took. See that, class? Now the next one, we're not going to do it for you. This one was the actual path it took. Everybody see that? Okay, that was the first one. Okay. Now it says place. We did that one, right? Okay, now it says step 2. Okay, use the same speed predictor, send the mail. Okay, we did that one. Did that one. Now it says repeat steps 3 through 9 for position B and C. So now, James, for B. Now we're in B, class. This part you can fill out later. On B, okay, James, can you go to B? He's gonna move the track to B now. The track is, can you show them B, Jimmy, on the track? Are you able to see that? How it says B here? Is it hard to see or not? I can't see it at all because you can see it. Okay, good. Now he's on track B. Now, James, put your cone. Where do you think it's gonna go? Okay, class. Now on your paper, take a moment and put your X's. Remember, we are going counterclockwise. So where do you think the metal marble is gonna go when it leaves the track? Please put 3 X's right now for your prediction. I'll give you a second to do that. Okay, now James is going to send it through. Let's see if he's right. Oh, he was right that time. Okay, so you saw what happened. This time I am not going to write it down for you. I want you to write it down. Go ahead, James, can you try again and see if you're right? Did you see that, Jimmy? Were they able to see that? Come out the track? Okay, good. That was B. Now we're going to do C. Can you move it to C now, James? And we're going to try to move the paper. Can we move this so the paper is like the same way as the... So when they do this, you can see it. Okay, there you go. Don't you, Mia? You ready? So he's putting his prediction. There's his prediction. Remember now, class, for your prediction, please write down your prediction. Where do you think the marble's going to go? Let's see. Okay. Try it again. All right, good. So the path, we saw the path that the metal marble took, right? Now we're going to do the same thing, but this time it says you're supposed to use blue color for the metal marble. So I should have put that. I should have put that all in blue. I do have a blue marker here. So my prediction should have been in blue, and this should have been in blue. Okay, because it says use blue marker for metal marker, and then use red color for the white marble. So now we're going to do the exact same thing. Okay, now class, we're going to look at the white marble. Remember, we proved to you in the beginning that the white marble had a lower mass than the metal marble. So let's see if there's going to be any difference with the path that the marble takes because of the mass. Let's see if there's any difference. Okay, so James, we're going to start from the very beginning. We're going to make it a hole, right? Yep. And we're going to just send it around a couple times, James. So you can get, All right. Okay, now we're going to put it on A, and James is going to make it his prediction. Go ahead, James, put it on A. Okay, you put prediction first, where you think it's going to go. Okay, so I'm gonna put the paper the same way as that so that it looks the same. And then he's saying this time that his prediction is gonna be, James, you wanna draw it where you think it's gonna go with the 3 X's? Because I'm not quite sure where you think it's gonna go. So 3 X's coming out this way. Okay, any day now, James, it's okay, it's prediction. 3 X's. Okay, let's see if he's right, class. Okay, so, oh, okay. Try again. We're still recording. Okay, good. So you guys see that, Jamia? Okay, that was A. So you can see, class, you should notice something. Can you roll this one around, James? Can you roll this one? I just want to show them that you know something. Okay. You guys see a difference? Is there a difference? Is there a difference, James?
Yeah.
There is? Okay, try again. Okay. Now let's do position B. Position B, same spot. Let's not move that. Okay, we got now, class. Wait a minute before you start. Make your prediction using a red pen this time, or a red marker, the red markup tool. Okay, go ahead, James. He's making his prediction. Not with that marble. That's the wrong one. Okay. Okay, he was right on. So let's see this one did the same thing. Let's see. You guys see that? Let's try the white one again. Okay. Put that right back where it was. Let's try that one. You should notice something, class. Are you noticing anything? Okay, so We already did the B one, right? Position B. And you should have your answer now, and you should also have your prediction. That's the next one. Let's do C now. Please predict, where do you think the white marble is going to go by using 3 red X's? Where is a white marble going to go? Paper's going like that. So let's make it the same. See his prediction? Everybody see his prediction? Okay. All right, let's see. Can you hold on to that, James, so that it doesn't move? Hold this so it doesn't move. So I want you to try with this one and this one so they can see the difference. Or if there is a difference. See that, class? Doing a white marble. Do the white marble again. Okay. Now let's do the gray marble, the metal marble, excuse me. Are you guys noticing any difference? Let's see if we put it back here. How about we put it here? Will be any difference? Well, no, I guess our path is wrong. Try again. Okay, let's put that one back here. Okay. What, you wanted to miss it? Okay. You wanted to miss, then look. Oh, I can't give answers. Okay. Okay, good. Now, class, you've seen all 3 positions, A, B, and C position. And from there, you now should be able to figure out the path that it took. You should notice, why I can't tell you, because if we were in class, we have time to talk about our data. But I don't want to talk about it now. Okay. Now, let me ask you a question. What forces would eventually slow the marble down? Anybody know? What would, James, you know? Jimmy, do you know? What force would eventually slow down the marbles?
Friction.
Friction. Absolutely. Friction would slow down the marble. So let me ask you a question, James. If we were in a frictionless environment, would the marble go on forever?
Yes.
Okay, well, we're going to find that out, class. We're going to find out. All right, well, class, that is the end of our activity. What you're going to do, after you finish all that, you're going to fill out your observations, okay? And I'll tell you more detail about that in the assignment. And then you have analysis questions. You have, and also an abstract. Okay. Oh, and my other class has, they have an actual lab report to do. So class, thank you, and bye-bye. Oh, I almost said bye-bye too soon. Let's say hi to, thank you to our helpers. Let's say thank you to James and my daughter. Let me show you Jamia and my daughter Jamia. Thank you, Jamia, for helping. And now my famous goodbye. See you in class.